In the last video I showed off all the features of this box, but I've made a couple of changes. But just to recap, what we have here is an SAE connector for the solar panel to come in. We have two DC barrel jacks. They're 5.5 millimeter by 2.1 millimeter. Those two are also solar inputs. They go to the solar charge controller. And then this third one down here goes directly to the battery in case you want to charge it or jump it or whatever you need to do with that. And then on the other side, we have the power switch that turns on the voltmeter, which is also USB quick charge 3.0 ports, two of them there. The switch also turns on cigarette lighter plug. And these four jacks are all on all the time. These three right here are the regular 5.5 by 2.1 millimeter jacks. And then this one is a 5.5 by 2.5 millimeter jack for something bigger like a TS100 soldering iron. These panels here that mount everything were all 3D printed, along with the clamping mechanism that holds the panels in. This plastic clamp that goes around that it just screws together and holds the fascia on. It's all 3D printed, and I'll leave links to the files for the Thingiverse files in the description. We've got just a cheap, this is, I think it was $11 on Amazon, free shipping, solar charge controller, no name brand. It works just fine. And if you've seen my last video, you'll know that the battery I used was a 12 volts, 7 amp hour lead acid battery. Well, that battery was very big. It took up all the way from here to here inside the ammo can. It was heavy, and lead acid batteries can't be recharged as many times as lithium can. So now, if you'll notice, in here there's a big empty cavity, and that's because what I have inside now is a lithium iron phosphate battery. It's a 6 amp hour battery, and it's actually small enough that I can fit two of them in there. Now, they cost about 30 bucks, so I haven't bought a second one. But as you can see, the mounting structure that I 3D printed has the room for a second battery in there. Now, like I said, it's a lithium iron phosphate battery, which has almost the same capacity as the lead acid battery did. This one's a 6 amp hour, whereas the lead acid battery was a 7 amp hour. And so for the same almost the same capacity, it's half the size and considerably lighter and can be recharged 2,000 times, whereas I believe a lead acid is around 200 times. Now, of course, when dealing with lithium batteries, safety is a concern, but these ones have their own charge controllers built in so that they can't be overcharged or overcurrented. Now, that actually brings up somewhat of a problem when dealing with a solar charge controller, and that's because when these batteries, these lithium iron phosphate batteries, once they go below 10 volts, they output 0 volts. So even though the battery itself has 10 volts still on it and could still power stuff, if you let it draw down less than 10 volts, it's going to shut off completely. And the solar charge controller needs power from the battery to charge the battery. If the battery's not outputting anything, you won't be able to charge the battery again. So you cannot, under any circumstance, let the voltage of the battery drop below 10 volts. And so what I've done to mitigate that is actually in the settings, I have the solar charge controller cut off the output load at 10.5 volts. But in the case that that does happen, that's why I put a jack that's directly to the battery so that I could use another 12 volt battery to start charging the lithium battery that's in here until it gets to a voltage high enough where it can rely off the solar charge controller again. Big change number 2 is I added a power meter for the solar panel. What this is going to do is it's going to keep track of what the current voltage that the solar panel is generating, how much current is going into the battery, how many watts and how many watt hours it's charged. It does have a blue backlight, so it can be seen in the dark, and I can turn that backlight on and off just by pushing this. Now you may notice I have a glob of hot glue on the button here, and that's because it was recessed before and it was really hard to press without a tool or something to push it with. So I put a glob of hot glue on there to make it easier to press, and now it's much easier. I also lined the inside of the screen with hot glue, same with the outside, and all the panels. And now it's not the prettiest thing or the most waterproof, but it adds a bit of water resistance to everything, and that way if there's any bit of rain outside, if I leave this box outside to charge and it gets some rain on it, at least the components that are not already waterproof. And just to mention, all these have their own little rubber plugs and stuff, so they should all be fairly waterproof, or water resistant rather, because nothing is waterproof. The hot glue is just going to add a little bit extra protection against the weather. So if you're looking for a fun project that isn't really too difficult to build, especially if you have a 3D printer, it makes it a lot easier, but again, you can build everything just with pieces of wood. I highly recommend building it yourself because it's a lot of fun. Thanks for watching, and I'll see you guys in the next one.